Welcome, everybody. It's office hours time. I got to stop whacking that table. I can see the camera do this every time. Welcome to office hours again. As always, sing out on the chat line if you can't see me or can't hear me. Hopefully I've sorted out all my audio technology stuff working as it's meant to be. Can someone throw something on the chat just to make sure you can actually chat? Because I always forget to turn that on. Let me have a quick look. Anybody? Awesome. Thank you very much. Welcome to user one. Not lovely bit of anonymity there. Once again, apologies for missing office hours last month. I was at the K-Scope conference in Nashville, hence the little tourism shirt. Had a great time there, met lots of fantastic people, got lots of travel coming up as well. I'm very fortunate, but managed to squeeze in office hours for August. Lots of good stuff to get through. Let's get straight into it. Let me share my screen and we'll be good to go. One moment. Okay, good. Hopefully we're good to go. Once again, if you can't see me, see the slides, not on the chat, good, then we're good to go. So as always, getting in touch is easy. You can just scan the QR code or go to linktree/Connor or Connor McD. That's my Twitter DM. DMs are always open. Love talking technology. That doesn't mean I'll always get back to you super fast. Oh, the sound is a little weak, says Judith. Okay, hold on a second. Let me move the microphone a bit closer. How's that? Is that a little bit better? I'll move it in a bit closer again. Hopefully that's okay. Hopefully we'll see how we go. That's about as last. Thank you, Judith. Better now. Okay, cool. I'm glad it's not my ears that are getting bad as we all, I won't say get older. That'd be an offensive trend, just as we get a little bit more senior. So as I always say, if you're new to my office hours, please do not adjust your set. We put the content sort of at the left or at the bottom such that when we turn this into a YouTube video, we can put my ugly mug on the top right and it doesn't cover any of the content because there's nothing more irritating than when the speaker covers up that one piece of code that you were desperate to see when you came back and watched this in a video. Now, word of warning, this is the BIOS screen from my PC. And about 4 hours ago, I was just working away, getting the last few slides ready, and boom, the whole thing evaporated and it came up on the BIOS screen and wouldn't get any further. It refused to boot. So that was fun. Nice little bit of panic there. I then turned the machine off, unplugged it, left it for a few minutes, knelt down, a bit of prayer, and it has come back on. So if some stage during this hour, all of a sudden the office hours seems to have come to a somewhat premature conclusion, hopefully it's not my machine evaporating, but hopefully we'll get through it. A few bits and pieces talking about things that are coming up in relation to user groups, things that have just been gone by, and some stuff hopefully that'll whet your appetite for Oracle technology coming up in the near future. Let me move my keyboard so I can get my microphone even closer for you. So first of all, unless you've been living on a different planet, we've got Oracle 23 AI out there. So you can now get the free version. You can download it from Oracle.com database 23 AI. You can also get it on our cloud now. You can get the base database service 23 AI. You can also get a autonomous version in its free format. We haven't got the full autonomous, I don't think, out there yet, but you can get free autonomous database, once again, letting you sort of dip your toes in the water to make sure that everything's going to work as you'd expect when the full release comes out. And if you're on an Exadata machine or a Oracle data appliance, an ODA, then yes, you can now also download and use 23 AI on your on-premises machine. Speaking of on-premises, no, I have nothing for you. I would love to say that Larry Ellison regularly calls me for advice and says, hey, Connor, when do you think's a good date to release on the on-premises release? No, I don't walk in those circles, funnily enough. So only Larry Ellison knows the date as to which these things come out. So feel free to flame me in the comments or hit me up on Twitter. But yeah, it's not like I'm trying to withhold anything from you. I literally do not have that information. So hopefully it'll be out soon. I know we're all waiting for it. We're all excited by it. And hopefully we'll all be able to download it and run it on premises soon. Other bits and pieces, this is a slide that'll be in my deck probably for the next 6 months. Please, if you haven't started playing with the SQL Developer extension for VS Code, the #1 probably development IDE platform on the planet. If you're not, basically you're checking out SQL Developer, this is the future. Someone said, Judith, what are you going to upgrade live SQL to 23 AI? Yes. Okay. I'll put that. I'll push that through. There is a new live SQL being built, a wholly revamped one, which I think will include actually you can actually choose a particular version that you'd like to run a particular piece of code on. So watch this space, Judith. It's coming. So yeah, if you haven't used this, be aware that SQL Developer, the conventional Java IDE, it's not like end of life, but very much our focus is on SQL Developer for VS Code extension. So start training yourself up on that. It looks very similar to the existing SQL Developer, but with all the bells and whistles that come with VS Code. Other cool things. Cloud World is just around the corner and the agenda builder is now live. So if you're coming to Cloud World, you can go to the Cloud World site and you can actually pick and choose the sessions you'd like to go to. Be aware that once sessions fill up, you can actually book your slot here. When you come to Cloud World, it's those people that actually book their slot in advance that actually get first dibs at the room. It's only when those people have got in, then all the stragglers are allowed in. So be aware that rooms do fill up. And so if you don't want to miss out, jump onto the agenda builder and nominate your sessions. I, of course, would be very, very privileged if you were to choose some of mine. Places where I'd love you to come say hello in the next few months coming up. I'll be at the Polish Oracle User Conference. That's in mid-October. And as is the case at Oracle, whenever I travel to Europe, obviously it's a long way, I try to do as many events all on the same trip as possible, because that way it saves our company money and it gets, it's the most practical use of my time. So I'll be at the Austrian Oracle User Group shortly after the Poland event. I'll be then hopping over to the Netherlands User Group. They're running an event there on October it says 7th to the 24th. I think it's actually on the 16th in the Netherlands. So if you're in the Netherlands, come say hi. If you're in Croatia, same thing, come say hi there. I'll be on the, because I'm doing all these events, I'll be on the second day there. I can't get in on the first day, but that's a fantastic event if you get along to the Croatian event. Then I'll be heading over to Spain for the Spanish Oracle User Group. That's a combination of tech and application. So all the different all the different flavors of Oracle all packed into one glorious day. And then finishing up in Copenhagen. I've done a talk Copenhagen last year at the user group. Fantastic bunch of people, very keen, very passionate. So really looking forward to getting back to Copenhagen. So all of that I think is in October. It's going to be a busy October for me. Somewhere in there, we suppose we have to try sneak in an office hours, but we'll do our best. All these things are once again saying, as I always say every single month, whatever region of the world you are in, please support your local user groups. There is nothing better than having those face-to-face communications. I did an interview with the UK Oracle User Group this week, and we were talking about the fact that people say, is there a future for user groups because of things like blogs and YouTube and videos and educational content and so much stuff out there? But I don't think you can put a price on the ability to actually share information as a community, talking to each other face-to-face, sharing each other's challenges, successes. I think that's how we all prosper. So let's move on. What have we got today? How am I going for time? Oh, we're about spot on. So lots of goodies to talk about tonight. We're going to talk about reserved words. We're going to talk about the lateral keyword when it comes to joins. We're going to talk about primary keys for partitioned tables. We'll talk about password security when it comes to upgrading through the various versions of the Oracle database. We'll touch on the recursive with statement, the with clause I'm sure you're all familiar with. We're talking about the recursive variant of that. We'll talk about some new Apex export options that came in release 24.1 that might catch you out unless you're aware of them. Too much parallel. Someone reached out to us and said, every time I run something, it seems to use parallel. What's going on? We'll explore that. And if we get time, we'll talk about how to pass in arguments to SQL+ scripts and some of the nuances involved in that. At any time, you can just bang out in the chat line. If you see my head tilt this way, it means I'm doing my best to keep an eye on the chat line. And we'll see how we go. So let's get straight into it, and we'll see how much we can get done in the hour we have. Number one, reserved words. Here's the question that came in. We created a function that has a reserved word as its name. Now we get errors when we try to call it. If we can't call it, why does Oracle let us use the name in the first place? It's an interesting sort of catch-22 or chicken and egg. And so without further ado, I think we'll get straight into a demo to actually explore the subtle nuances that come when you're dealing with Oracle reserved words. Okay, everyone can see that. I remember last Office Hour, I did a full demo and no one could actually see it. So sing out in the chat line if you can't. I haven't stuffed up, but I think hopefully you can all see my SQL Plus session. So I've created a function here called count. And unbeknown to me, I've chosen a reserved word, namely the keyword count, but I wanted to count something, so it seemed intuitive to use the word count, and the Oracle database lets me do that just fine. It doesn't complain. Of course, the moment I try to call that function, I'm just trying to output its return value here. It says, I'm sorry, you can't do that. You can't use the word count inside DBMS output. That seems a bit weird because why did it let me create the function in the first place? Well, maybe it's just the case. Maybe I need to use uppercase count and see what that happens. But same thing, I get the same problem. Oracle is case insensitive when it comes to dictionary by default, in that it assumes everything is uppercase. I can actually call the function. If I actually put my count in quotes, then I actually do succeed to get through the checks. And yes, the Oracle database will indeed call my function called count. And so you can actually see it can be done. But let's have a look at what's going on. If I look at the reserved words view, and yes, we do actually supply a view called $reserved words, which has the list of all the reserved words in the Oracle database. And rest assured, there's many of them. And as each version goes on, more and more keywords become reserved. But notice there for each keyword, we have the length obviously, but we have these extra columns: reserved, res type, res atta, res semi, etc. So let's explore those a little bit further. Let's tackle this count keyword. What happens with the word count? And if we look at the $reserved words for the keyword of count, what's interesting is it's actually in there, but if you look at reserved, it says no. Res type, no. All the res columns say, yep, it's not reserved, but it's in the reserved words. That's a bit sort of counterintuitive, but its presence in reserved words means it's special in some way to the Oracle database. But those other values are saying that it's maybe not as significantly reserved as some other things may be, and we'll explore that a bit further. What's interesting, Lizzie, if I actually went to extend that a bit further, if you want to mess with your friends at work, create a function called count1 or count anything like that, because you could have some fun with this, because then when someone does select count1 from scott.emp, they'll do a correct select count star effectively. They'll get 14 rows. But if they were to happen to put it in double quotes, they'd actually get the 14 rows back because they're now calling the function. That's just a bit of fun there if you want to mess with your friends. But if we look at reserved words, we saw that count is not not flagged as reserved, but let's see what actually is. If I look at reserved equals y, and I'm just grabbing a random sort of 10 rows here, you can see there are some things that actually are listed as reserved and tagged with reserved equals y. We see things like with, where, view, varchar to, varchar, etc. So the question is, why are they tagged as y, and how does that differ from, say, count, which was in reserved word, but not tagged as reserved equals y? Well, this is the first sort of suggestion we can see how it's different. If I do create or replace function varchar2, unlike the count keyword, which I was allowed to use it, varchar2 is not allowed to be used. It is slightly more reserved than the keyword count. And that's what reserved word is trying to sort of indicate to us here. It's reserved effectively across the board in all cases. You can't use it even in a function declaration as opposed to count. Let's go look at, for example, res atta, which is res atta equals y. And it says the things which are not marked as reserved, but they are res atta, which I'll make a logical leap here and assume that's a reserved attribute, are things like nested table ID or column value. So let's grab that first one, nested table ID, and see how it's protected in some way. Similar to count, I can actually create a function called nested table ID. The database doesn't mind that at all. So that's because it's not tagged as reserved equals y. If I drop that function and try to create a type which has as one of its columns nested table ID, I get an error. This value is reserved if you're using it as an attribute. That's my hypothesis here. And nested table ID inside an object would be an attribute, and it's not allowed to be used because it's reserved with res atta equals y. It says that's invalid use of a type name or subtype name. So hopefully that explains a little bit how there are different layers or different levels of how reserved something is. That's why you can actually create things like functions with certain reserved keyword names and not others. My recommendation is, like, just steer clear. Now, that's a very flippant wave of my hand, like, just don't use them. I understand the fact that if you go into VDOLAR reserved words, there's literally thousands of entries in there. And of course, times change. In fact, my very own AskTom database, which we use for the AskTom system, many of the columns there that have date information in them are actually called timestamp. The actual column is called timestamp because when AskTom was first built, there was no timestamp data type. So we just have to accommodate that. We use a lot of double quotes here and there, and we should get around to renaming the column. So I understand that the world changes as the versions evolved, but obviously save yourself the pain. Just steer clear of reserved words as best you can. So hopefully that helps clear that up. Lateral. Here's the question that came in. I'm old school. So am I. So I generally just stick to the Oracle syntax for joins. I can see the functional equivalent of left, right, full join, etc., etc. But why would I ever have the need for lateral? So let's explore lateral and see why a lot of people actually think lateral is one of the great joins, one of the great joins. So even to me, and as an old dinosaur, I think lateral is extremely cool. And the reason I think it's cool is it's less about the functionality that it offers. It's more about the way it lets you write SQL. And I put here, I think, it's about the mental model that lets developers build SQL more easily. So we'll do a demo here, which hopefully explains why I think lateral might be your go-to join for many, many cases. So I'm going to start with our familiar employee table, 14 rows, just the various Scott.emp table. And I'm going to introduce a new table now called employee bonuses. And for a set of employees, over time, they get the occasional bonus. You can see here that employee 7369 on the 17th of December got a bonus of $100. If we scan that a bit further, a couple of years later, he got another bonus, etc. So it's a one-to-many relationship between the employee table and this employee bonus table. Now, you might be given a requirement, that is, list each employee and retrieve their bonuses and when the bonuses were granted. This is a module specification, or in the Agile world, a yellow post-it note that we stick on the whiteboard somewhere, and that's our requirement. If I'm a developer, especially if I'm maybe a bit of a novice when it comes to SQL, I'm going to start with this requirement and tackle it in a procedural fashion, even though SQL is a relational or algebraic set-based language. So for me, I'm going to list each employee, and I need to get the bonuses for each employee. So first thing I'm going to do is, okay, how do I go get a bonus for a given employee? So I grab an employee at random, 7369, and test this little small query. Yep, that's how I'll go get the bonuses. Okay, that's fine. Now I need to extend that for an arbitrary employee number because I'm going to fold this query into my list of employees. As a developer taking a procedural approach, this is the sort of mental model I'm going through here. I can do it for one employee, which means I can do it for any arbitrary employee. That means I just fold this query then into the outer query, which is the list of all employees. This is my mental model. I go get every single employee. That'll give me an employee number. Now that I've got that employee number, I can run this query that I've just crafted myself. Go get for each employee, all the bonuses. This is the mental model of building up a join. Of course, there's a problem. When I run that, you can't do it. The inline view here is not allowed to refer to other tables in the join. That's invalid SQL. Unless, of course, you're using lateral. And this is why I like lateral. It is effectively just a join, but it lets us explore that mental model of building up a query from the inside out to the outer layers. All I've done here is add the lateral keyword in, which now says this inline view is allowed to refer to columns from the joined table. So it's nothing really special, but in terms of building SQL, I think it's very, very impressive because it lets you take a procedural approach to a relational problem, very similar to the way we use the with statement sometimes to effectively take a big problem and tackle it step by step. So lateral, I think, is actually a very cool join because it lets you explore SQL in a programming style of model. Now, people say, well, hold on, I don't need that kind of stuff. I've been using Oracle for this many years. I know how to write a join. I can just comment out the lateral and just join an employee bonus and just do that. Like, it's that easy. That's just, remove those lines. Why wouldn't I just write it like that? I get the same result, the same recall the result we just got from the lateral thing. This is true, but of course, applications generally don't have sequels that trivial. What if your requirement was this? List each employee and find the largest bonus they received and when it was granted. So once again, I'm going to build this up in that mental model. Okay, for a given employee, I'll pick one at random, 7369. How do I get the highest bonus they got and when? I can just do order by amount descending, fetch first one row only. That's a nice simple query that gets me the highest bonus and when it was granted. Now, that means I can do it for an arbitrary employee number. Here's my sample query. That means I can definitely do it for an arbitrary employee number. And using my lateral, I'll just do the same thing. I'll simply take every employee, use lateral, and then pass that employee into my inline query, and the job is done. And I get this lovely result. Once again, I didn't have to worry about the complexities. I managed to build this query up, and the lateral let me effectively, cheat on the join rules. How about rewriting that without lateral as a join? Well, that's non-trivial. There's various ways you can do it. Here's one example. I'm doing my join as I did before now, my direct join. But what that means is obviously I'm getting multiple rows for every employee for each of their bonuses. So I need to assign some sort of sequence number to get the highest bonus they got and use partition by employee number. And then wrap it in an inline view and get the number one version. So yes, I can do it just with a simple join, but that's perhaps not as trivial to write and much more takes a bit more mental gymnastics to come up with the same answer. This is why I like lateral. It avoids these kind of complexities. The question is, if a normal join could do the job, well, what does the database do when it sees lateral? And we can explore that. I'm using dbms utility to expand SQL text here to see what the database does when you actually pass in this query. And unfortunately, what it does is dbms utility expand SQL text sort of looks at this too early in the piece. If I print that out, the database, although it's a bit wrapped here, you can see it actually hasn't changed it. It says, yes, this is the query you sent me. This is the query I will be running. Nothing gets changed. To actually see what the database is running, we have to go a little bit deeper and look at an optimizer trace. So I've turned on event 10053 here, which means it will dump out an optimizer trace, and I'll explain this lateral. Now on Windows, I have to disconnect from my session to close the file, the trace file, but once I've done that, I can just hunt around in my trace file for the final query the optimizer was going to use. And notice with my source query, which was a lateral, the database said, well, I can just rewrite that as a plain old join. So the database is quite happy to take your lateral queries because it just rewrites it as a normal join anyway. That's pretty cool. We didn't have to worry about the fact that we had to do the work. We just wrote the lateral and the database looked after the complexities. Bang on the microphone. One of the interesting things here is when I first saw this, I thought, maybe the database can't natively run a lateral command. Maybe all laterals have to be taken, rewritten to their equivalent non-lateral or sort of conventional join in order for the database to run them. So then I turned back on a 10053 trace and looked at the slightly more complicated example we tried, which is employee lateral, and then with the order by and the fetch first in there. How will the database rewrite this? Will we see the row number kind of stuff we saw before? In my optimizer trace, notice lateral still is there. In fact, besides a little bit of subqueries and stuff, and we had the row number in there as we wrote manually, it still has the lateral in there. I find this quite interesting because it means the database can optimize a direct lateral syntax. So why did it rewrite the other one? I don't know the answer to this, but interestingly, the database can actually deal with lateral natively, but we can see on some circumstances, it will rewrite the query to remove it. Other uses you might find for lateral, besides just making joins easier, is sometimes you definitely want to have a correlation between two queries that could be hard to work out otherwise. For example, if I've got some data like this, which is for each department, I've got a concatenated string of each of the employees in that department. That's not great relational theory, and we want to turn it into rows. What I want to do is do a substring of this big string and hunt for each of the commas. But of course, how many commas are there? Well, the only way I know it is actually by doing a count of the number of commas in that string. This is where lateral can be very useful. I go into my company table, For each row, I'll take this and I can actually do a connect by, which means I'm going to loop round once for the number of commas in this expression. Once again, the ability for this query to go reference a column from this table, in this case CMs, makes this very easy. So when you're converting things like strings to rows, the ability to use lateral makes these queries, once again, very, very easy. I like lateral because it lets you build joins in what I suspect is an easier way. As a building block model, start with the inline query and simply attach an outer query to it, and then be attach an outer query to that, etc. You can just keep lateraling all the way down to effectively make your queries easy to build, and the database looks after optimizing them in the appropriate way. It's all quiet in the chat line. That's either a sign of a good thing or the fact that people are falling asleep. We'll see how we go. Partition indexes. Now here we go. Oren. Oh, I knew Oren would jump in with something cool. The optimizer used lateral even in 11G, maybe before it became official in 12C. And you'll see a lot of that in the Oracle database. Classic example is the LNNVL function, which was a function that you'd always see in your execution plans all the way back to about Oracle 8. And then we said, we've been using this now for 20 years. We may as well stick it in the documentation and let people use it themselves. And I think it came in along about 8, maybe 12 to or 18. So it's one of those funny things. You see a lot of stuff in the optimizer plans that aren't documented, and then slowly over time they become documented. Word of warning, lateral is not one of these word of warnings. If you see it in the execution plan and it's not in the docs, please don't jump in and just think, I'm good to use it. Classic example, sysop map non-null is a function a lot of people use. Just be aware that if it's not in the docs, you could be in for a tough time if you have a problem, because when you call support, they're just going to go, not our problem. Okay. What was I talking about? Partition indexes. Here's the question that came in. Archiving our old data is taking too long, so we want to partition our large transaction table. We've hit a problem with our primary key because it has to be a global index. How can we solve this? In terms of solving a primary key being a global index, generally you can't solve it just by saying, I don't want it to be a global index, but you have lots of options that you can explore. So let's have a look at the classic problem. I've got a table which has let's say a conventional primary key of just a sequence number, and it's got a simple big index over the table. You said, I'm going to partition this table. How am I going to manage this sequence number when it comes to archiving data? Because what I want to do is drop partitions, but if I got one big giant index over the top, then that could be problematic. So that we wouldn't have to sit there and stare at the screen for 5 minutes, I prepared this earlier. I created a table called tPartition. It's partitioned by a range pdate or pardate, and I got 2 weekly partitions. So I built it with 7 partitions. It's interval so it can grow to more. And what I did is I put 400 copies of DBA objects in there. That's why I won't subject you to it now, because it takes a fair while to run, but hopefully it's there. Otherwise we'll have to stop and wait. And let's have a look. So it's got 34 million rows in it. 34 million rows. Each partition's got about 5 million rows in there. So that's a nice, big, healthy table. And it's got a single table. It's partitioned. What we want to do is put a primary key on it. So the way I'm doing it, I'm going to create a unique index on our primary key column. That's just a sequence number that goes from 1 up to 34 million. I created it in parallel 8 to keep it nice and fast. We'll make it non-parallel, and then I'll simply add it as a constraint. So what that gives me is a nice big index across my entire table with my primary key constraint on this column called PK. Now, one thing I should note, just to a little segue here, you might be wondering, why did I create the index and then do alter when I could just do alter add? Oracle will let you use this syntax. Add a constraint primary key using index, and actually had the create index command straight in there. It will happily let you do that, but what it won't tell you is it silently ignores the parallel 8. You can run that, you won't get an error, and it'll take 8 times longer than what you just saw because the parallel clause is ignored. So be aware that the only create index you can have into here under using index will ignore things like the parallel clause. So be aware, if you want to actually take advantage of parallel, you need to separate the two. That was a discovery I made today before my machine died. Just to prove that when I did this, even though my table is partitioned, my index is not partitioned. It's just a single big index that sits over the entire table. It's a global index. So let's have a look at the options here. I've come to that point where I want to archive some old data, and rather than delete it, which takes a long time, I'm just going to drop the oldest partition. The great thing about that is, as opposed to having to delete the data, as this original poster has asked, now it's instantaneous. Dropping old data is like 0.02 seconds. That is fantastic. The problem of archiving data has disappeared. There's one slight problem. Because this index sits over the entire structure, it has now become breathtakingly unusable. Unfortunately, what that means is your application is now dead in the water. If I try insert a row, I'm sorry, your index is unusable, which means you can no longer do any operations on that table. That's not so great. So let me rebuild that index to get it at least back into a nice usable state. So now we can actually use our table. But you can see here the problem with global indexes and wanting to archive data by dropping a partition. They don't really sit hand in hand that nicely. Now, my index is 680 megabytes. I just want to note that down so we can see what happens to its size as we do some more operations. As we saw, just dropping a partition generally isn't going to be a favorable way of dealing with your archival scenarios because you break your table. So way back in, I think, Oracle 9, we introduced this one. I can actually drop another partition. This time I want to update the indexes. Now this is good because what it does is it actually says, yep, I've managed to drop that partition and I haven't had to change the index structure because I managed to update the data inside the index. The price of that is you can see by the time. Rather than 0.02 seconds, took 4 seconds. And you can imagine what it's doing is it's cleaning up the mess as it drops that partition. It's in effect doing the delete from the index that we would have had to do anyway if we ran a manual delete. If this table had billions of rows, then that could be a very non-trivial exercise. 4 seconds because I made the table small enough for this demonstration, but for a real large partition table, that could be very, very expensive. And notice that even though I dropped that entire partition, my index, which was 680 megabytes, I've just wiped out a whole lot of stuff from it. It's still 680 megabytes. I didn't get any space back. I just removed the entries that were no longer appropriate from that index. The best part is my index stayed valid the entire time, which means my application is not broken. I can now continue to indexes. This is why people tend to do this, because they say, I'll cop that hit of updating the index in order that my application stays up and running. But what have I really gained then? Because what I haven't done is actually improve the archival time because it cost me that time to do the deletion. I may as well just write my own delete statements. From 12C onwards, we did a subtle change which seems to give the best of both worlds, which is let me drop another partition and include update indexes, which should take 4 seconds, and now it's instantaneous. So how did we do that? How did we go keep an index updated and drop a partition and not have to pay that price? Table still works fine. I can still insert into it. I didn't lose, index is not unusable, so everything's fine there. This is what we did. We didn't actually touch the index. We set a flag that says inside this index now we have some orphaned entries. The index we left untouched, which means there's a whole swag of 5 billion rows in there, 5 billion entries in that index that point to vapor. They point to nothing because those rows are gone in the table. What we can now do is because a row ID has a pointer to an object ID, every time we scan that index, we say, okay, here's an entry in the index. What's its object ID? Oh, that object ID no longer exists. This is an orphan entry. I can simply ignore it. So the index remains its same size, but effectively I've managed to update the indexes at zero cost because I didn't actually do anything to the index structure. You can see here that that's a great thing because even though my index now contains some junk or garbage in there, my optimizer can still use it. If I do a select query where the primary key equals some known key, yep, I can still use that index just fine. It says, yep, I'll do a unique scan and life is good. However, what about something like this? If I say go get the lowest value from the primary key from my table. Now, anyone that's familiar with the optimizer knows that the optimizer has a special trick that lets it walk down one side of the index very efficiently to get the lowest value. It's called a min-max optimization. You don't see it here. What we have to do is we actually have to start scanning the index. Why does the database have to do this? Well, unfortunately, the leftmost or the lowest columns, the lowest entries in the index no longer necessarily are the lowest values in the table because there's garbage floating around in my index. The database actually has to scan through the index, effectively ignoring the junk in there in order to find its first valid value. So those orphan entries can actually have an impact on the optimizer depending on the queries you're writing. Hopefully it should be negligible because most queries are going to be where primary key equals some value. And that'll simply jump down the index in the normal way. It'll either find a value or find an orphan value and decide appropriately. But when you're scanning through the index, you're going to have to scan through some of that junk in order to find meaningful values. So be aware of that. Now, I've connected a sysdba and set this running because I want to talk about it and it'll take a little while to run. We can't just leave that orphan information in there forever. Well, we could, but obviously our index would get more and more polluted with garbage and having less and less value in there. And what's more, the index would continue to grow and grow and grow, even though a lot of the data might not be relevant anymore. So every night, the database has a job. It's run by sysdba. It's called PMO Deferred G-Index Mate Job. As you can imagine, Deferred Global Index Maintenance. Let's go look at all the global indexes in your system. Do they have some orphaned entries? Let's go clean them up. Now, even though I didn't have timing on there, hopefully you saw that it took a bit longer than when I did the drop partition update indexes, which took 4 seconds. This one ran for about 12 or 13. It's actually harder to come along after the fact because you have to scan the entire index for orphaned entries. If I'm doing update indexes in the old style, then as I drop the partition, I simply grab the row IDs from each partition entry and go to the index and delete appropriately. So this is actually slightly more expensive. Be aware that you're getting the benefits during the day to pay a larger price during the night. It's a balancing act here. Now you can see my orphaned entries are gone. The index has been cleaned up and the database has removed all the orphaned entries. And now when I do my min PK, because there are no more orphaned entries, I can actually do that min-max optimization I spoke about before. There's no junk in there, which means I can just walk down the left-hand side of the index for a min, down the right-hand side of the index for a max, and the database will work fine because it knows the index is clean. However, that global index maintenance job that runs is doing a removal of orphaned indexes or orphaned entries. It's not doing an index rebuild. You can see the index still remains at 680 megabytes. What we do is we clean up the mess, but we don't reclaim the space for other objects. New index entries will be able to use that space again, but be aware we don't give that space back to the table space. Let's rebuild it, and that'll show that now I actually have only 430 megabytes of entries in there. So be aware that they deferred global index maintenance. Yes, it gets your application in your partition drops instantaneous. Your application still runs, but you pay a price later on in the evening when that cleanup job goes on, and that space remains available only to that index unless you go ahead and do a rebuild. Let me drop the index now and let's explore some other options. I'm going to say I want to now create it as a local index. We just saw that we have some solutions in hand if we have the big global index, but maybe it's better if we actually have a local index such that the index segments are bound to each individual partition, which solves all the global index problems altogether. Let's try to do that, and we have a problem here. You can't simply grab a primary key column and say, look, let's make it local. If you want to have a local index that's used as a primary key, you have to have the partitioning column in that definition as well. That makes sense because otherwise every time we wanted to check for a duplicate, we'd have to scan every single partition, which means locking every single partition to see if a primary key entry is in every single one of them. So what that means is we have to have a unique index which has the primary key and the partitioning column in there, which is in case the date. And now I can create a primary key with this in there. Now, here's that interesting application compromise. And I've seen this used by customers in a lot of places. Yes, they know that the PK column is unique. And they say, well, what we'll do is, yes, I know that, but I'll modify my application such that whenever it inserts a primary key, it also remembers the date and that pair becomes the primary key. And we modify the application accordingly throughout to handle that. That's the price you pay if you want to have a local primary key. This makes index maintenance trivial. If I drop a partition, all my partition of that primary key stay usable, the application stays usable, everything's fine. So be aware of that. You can do it, but you now have to carry the partition date or the partition column around through your application. If you don't, you pay this price. If I went and did that, made the index local, but didn't change my application, I just said, I'll just use the primary key column as before, you get this. I'm coming in a query just with a primary key column. As I said, we don't know what partition that's in. So yes, I'll do an index range scan of my primary key index, but notice it has to scan every single index, every single partition. Now, there aren't a million partitions here. That's a consequence of it being an interval partition table. But all the available partitions must be scanned because that primary key value could be in any of them. That obviously is quite expensive if you have lots of partitions. If you had, say, just 3 partitions, you're running a 3 rolling months, for example, then maybe you could get away with it. You pay a 3-fold penalty, but be aware that you really have to be very careful if you're just going to carry the primary key column, even if you've locally partitioned it. If I am carrying the partition column around with all my applications, so my queries look like this, then as you can imagine, we're scanning just a single partition and it works just like a normal primary key. And you get all the benefits of being able to drop partitions with no index maintenance being required. One thing you might want to do is somewhat of a hybrid, which is I've seen this used at customers as well. They create a table called TLOOKUP, which is effectively this information. It's a primary key of the primary key and the date. In fact, that's a bug there. We only need the primary key of PK there. But what it is just the primary key and the date columns, nothing else. It's a thin version of my actual partitioned table. And I'll gather some stats on that. This is a table that I will never archive. It's very tiny. It's just a digit and a date. I'll let that grow forever. I'll never archive this. But what I'll do is every time our application inserts a row into my main table, I'll insert the primary key sequence and the date into this lookup table. Now my queries in my application look like this. I only have to pass in the primary key column. So the rest of my application doesn't change, but I do need to do a join now. This primary key lookup lets me get to the lookup table. This lookup table gives me the partitioning date. That partitioning date can then be used to actually join to my unique index that is partitioned on the true table. You can see here we're basically just once again doing single partition lookups, and we start off with our indexed organized table, which is our T lookup table. You still have to change your application to do this, till it looks like this, but that way I can now have a local partition primary key, but my application code only still needs to pass around just a key value, not the date as well, because it's being stored in this lookup table. If I drop a partition, everything works fine. All my partitions remain usable. That query I just wrote remains usable. It's only scanning a single index or single partition, and therefore we still get the performance benefits. So it's pretty cool. You could then mask that from your users by saying, okay, I'll create a table called, or a view called, I'll probably call it called T, or my original table name, which is just effectively all the columns from my real table joined to the lookup table with the various bits and pieces here. So now when someone does select from new version of my table with a simple primary key, they don't know that we're using this lookup table to get the benefits, and we've managed to implement a local partitioned primary key, therefore making all our index maintenance and archival things trivial to do. Whew, that was a big demo. So my recommendation is, as a general rule, is rather than the complexity of changing your application, see if you can get away with the asynchronous global index maintenance. You're paying a price outside normal hours, but hopefully you can then update your indexes in no time. You can drop partitions nice and easy, and you only have to pay an asynchronous cost in the background when we clean up those indexes overnight. If that becomes too expensive or those async jobs run too slowly, that they burn up too much resources, then look at that option I said in the second option, which is look at some application changes so you can actually implement a local partition primary key with minimizing the changes to your application. So hopefully that helps. I'm looking at the participant count here. I always like that. As the demos get longer, you can see the numbers start to fall off. But anyway, stay strong. Stay strong. Only 15 minutes left. Impossible passwords. We're upgrading from 11G to 19C. Don't flame me. I'm still 11G. Come on. And one of the trouble spots is we can no longer run alter user identified by values to create impossible passwords. Has this been blocked? So let's have a look at what they mean by impossible passwords. And no, we haven't blocked it, but you shouldn't do it. Let me explain with a demo. So I'm going to connect to my database here and create a simple user called demo, identified by demo. Not the most secure, but you get the idea. This is how originally we would tell people if this is for example, a schema that owns objects and no one should ever directly connect to it, because we never want people logging on as the schema that owns objects because they could do drop, truncate, etc. That's a bad idea. So normally we would recommend this. We say, go ahead and lock that account, which means when they try connect, the account is locked, everything's safe. I've done videos about this before. That seems really sensible, but it's actually a security risk. Why is it a security risk? Because what you've done is revealed information to a potential hacker. You've now told them that there is an account called demo on your system. The fact that it says account is locked means you've said, yep, by the way, we do have a schema called demo. Now you can try and hack into it. They won't be able to connect as demo, but if they manage to connect as someone else, then once again they go, aha, I know there's an important schema called demo on this database. So the account is locked was a great idea at the time, but it's actually a problem because it opens up the information to security or to hackers. If I go back to version 11 of the database, which is just running on a VM on this machine, we can see how we used to solve this because you didn't used to be able to do account locked, or even if you could, you didn't want to. You create a user identified by demo. If you went and looked in DBA users in the password column, back in Oracle 8, you'd see the password in encrypted format. In Oracle 11, we improved that. Back in Oracle 10, I think we improved it. You can't see it from DBA users. That's a good thing. But you could see it in sys.user$. So if you had a sysdba access, then you could actually see what the password was. And this was a hash that came out of the password demo. What that meant is as long as you could alter a user to be identified by values, something that could never be a hash function. That hash value was a piece of hex. This is obviously an invalid piece of hex, which means if someone ever tried to guess a password for the demo, they will never hash a password, any password that could ever end up as that, because that's not valid hexadecimal. This was good because now if someone tried to hack into your database, they'd get invalid username password. You haven't revealed to them the account is locked because it's not, but they will never ever be able to log on as that account because that's impossible, no pun intended, to have a password that would hash to that value. This is pretty cool. It doesn't reveal information and it's an account that can never be logged into. Fast forward to Oracle 21, or Oracle 12.2 onwards, but any modern version of the database. I try that and we start getting errors. So this technique that we all used to use back in Oracle 11 and before is no longer valid from 12c onwards. So what do we do? So just to give an idea for how this works, well, the thing of name and password being in sys.user, like we just saw in Oracle 11g, well, we tidied that up as well. That's now gone in Oracle 12 onwards. You can't even see it in the password column. If I describe sys.user$, there's all these other bits and pieces in there. And if you play around long enough, you'll find that it's actually now in spare 4. Of course, spare 4 contains the hashed password. And as you can see, it looks a little bit different to how it used to. We're not going to dive too much into this because we don't need to be looking at this level of detail anyway. But in a nutshell, because password hashing algorithms have changed to make them more secure as each version has gone on, you might come from an Oracle 11 database or an Oracle 8 database and move your way up to Oracle 19. So you might have one of the old hashes, maybe an Oracle 10G hash, maybe an 11G hash or a 12 hash, whatever. Depending on what hashes are there, then we might store them in various forms in this password thing. So we're handling the evolution of security in the Oracle database. But for lack of a better term, you can assume this whole thing is just a hash. And obviously that's the new hashed format in 12c onwards. So you can actually still see it. The question is, if I look at the DDL, get DDL, this is the hash that comes out. It shows that a create user command and an alter user command are still allowed to do identified by values. You just have to nominate these more complicated hashes now. You can't use the words impossible hash. It actually has to be a valid hash value. Similarly for the demo user, we know that demo is identified by demo, and that's its hashed password there, some big cryptic stuff of hex. So what that means is you still can take advantage of this facility. You just have to have an appropriate hash value. So I can do alter user demo, identified by values, and use this hash, all zeros. Now, you just have to take my word for it. And I asked the security guys, no hash will ever evaluate to all zeros. So this is equivalent to the impossible values hash. So you can actually use this alter user demo identified by values impossible hash in this format, and it'll work fine. But as you can see, you get invalid username, password, life's good. But don't do any of that. There's a better way. In Oracle 18 onwards, we solved all this nasty, ridiculous stuff about meaningless hashes, impossible hashes, and stuff like that. We simply said this: create user demo, no authentication, which simply says there is no hash in there because you can never connect as this user. Also, if the user already exists, I can simply do alter user demo, no authentication. And now I can't connect to it. There is no password you can try because there is no password. So this is the way you should be doing it. Now, one caveat I will say here that's important, and this applies to any mechanism you use to make a user unconnectable. If I create a user called demo1, and I added here just to show you that you don't even have to put no authentication. If you just do create username, then that's a user without any authentication. If that user has create session granted to it, then you can still do a proxy connection. So if I run the following command, you are allowed to get into demo1 schema if you come via Scott. Then even though this user has no authentication, then a proxy connection connects Scott with Targa, that's Scott's password, and end up in demo1 lets me in. It lets me in as demo1. So even though demo1 never had a password, never had an authentication system, if demo1 can have a session associated with it, then a proxy connection will let it through. So just be aware of that. The old impossible hash things is no longer allowed. It's once been replaced with no authentication. So as I've said, don't use silly hashes anymore. You don't need to. Just use no authentication. We might get through this one. I don't think we'll get through the others, unfortunately, because I talk too much. Recursive with CTE. Here's the question that came in. The examples of recursive with I've seen on blogs, etc., are all the same, tackling theoretical problems like towers of Hanoi, rabbit breeding, rabbit populations, etc. All these theoretically, Fibonacci series, factorials, all these sort of classically recursive problems, none of which you'll use day to day. Yeah, let's face it, you're never going to use it. And someone said, are there actually any genuine business use cases for recursive width? And I say yes. But first, I need to give you some background, this might take us to the end of our session today. This is probably what most of us, anyone that's used Oracle for more than a few years, is probably most familiar with. If you want to do a hierarchical query, you use connect by. You have a starting point, and then you establish a rule for how you're going to get from one row to the next. So in this case, a manager is the prior person's employee number, and we get this top person goes to this person, etc. I've simply done some R padding to make it look like a hierarchy. Let's go back to first principles. So if I look at this query, if I didn't have the connect by clause, and in fact, connect by was one of the first things we implemented in Oracle back in Oracle 2, believe it or not, you had connect by. If we didn't have connect by, how would you traverse a hierarchy? Well, you have an entry point to the hierarchy. So I'm going to start where the manager is null. That gives me the top level in the hierarchy. That's the first query I would write. How do I get the next query? Well, I need to take these results and then join it back to the employee table. So I'll take that query and say, okay, now, given that that's the employee numbers at the top of the hierarchy, let's join it back to itself to get the next level down. So this is level 2 in the hierarchy. These are the people that report to King. Now I need to get to the next level in the hierarchy, which is all the people that report to these 3. So now I take this query and nest it in a join to the employee table. Once again, the exact same logic here. These are all the people that report to the 3 people we just saw. This is the next level down. How do I get to the next level? Well, I take this query and nest it inside a join to the employee table, and so on and so on. We just keep nesting it down. For each set of results I get, there's the first set of results, there's the second set, there's the third set, there's the fourth set. I do a union all, and there's my hierarchy. You can sort of see why we invented connect by now, because this is obviously hard to write, and you'd need to know how many layers to keep going down. You need to know how many levels you theoretically have in the hierarchy, but from first principles, that's how the hierarchy queries work. So if we look at this last example, the fourth example, you can see from the indentation, there's sort of this, policy of that is just a extended version of that, which is an extended version of that, extended version of that, etc. You start to see that this is a recursive pattern. And so that's the sort of hopefully the light bulb moment that says, maybe recursive CTE is not just for theoretical mathematical problems. It can also be used for navigation of a hierarchy. And that's exactly what it can do. So I'm going to start with, as we said, from first principles, we walk through levels of the hierarchy. So I'm going to have a recursive with here called the employee level. I need to start with level 1, like our first principles. First principle was, let's get where the manager is null. That gives me that row, that number first row that was just for employee king. What did I then do? I took that query and joined that query back to the employee table. And that's what I'm doing. I'm going to take this query, I'm defining it here, and join to the employee table. This is where I'm establishing that same indented recursive relationship that we just saw from first principles. Now, what did I do with all those individual results at the end? I did a union all, and there's my query. So this is effectively the recursive version of our first principle hierarchical navigation. You can think of it this way if you like. If you want to map a connect by query to a recursive with, the top part is your start with, and then the second part is your connect by. Effectively, this is where we enter the hierarchy, and this is how we get from one hierarchy to the next. So yes, if you are new to Oracle, you probably wouldn't use connect by. You would use this. This is actually the ANSI standard for going through a hierarchy. It's not just about theoreticals, it's about navigating through hierarchical structures. Now, are we going for time? We're doing okay. Now, if we have these new recursive with to navigate a hierarchy, we need to be able to implement the other cool things that we've always had in the connect by query. Things like the level, indentation, syst connect by path, connect by as cycle, order siblings, etc. Because we now have control to each individual level of the hierarchy, we can actually do it very simply with first principles. The first entry into the hierarchy level is level 1. Each time I recurse through one level, what happens? I'm adding one to the level. I can get the level function out just by doing first principles. I've called it R level here. Can you guess why? Because level is a reserved word and you won't be able to use it. What if I want to do indentation? Well, same thing. Indentation, if I want to pad out my hierarchy left to right, well, at the lowest level, there's no indentation. At each subsequent level, I would indent by the existing level, adding a couple of spaces. Slight problem occurs. I get the result of string concatenation is too long. By default, it's assuming this is a varchar to 4000 or your longest length, and therefore I'm trying to add another 2 to it. So to work around that, I would do a cast. Let's start with 100 characters, and therefore I can continue on, and there's my indenting, once again done from first principles. If I want to do, for example, syst connect by path, syst connect by path in the old style lets you build up a string of the entire hierarchy chain. Same thing. What happens here? At the first level, right? The first level of concatenation is just the employee itself. As I recurse through, I take the existing names and concatenate the current name. That gets me King, King Jones, King Blake Allen, etc., etc. Just building up from first principles these objects. What about cycles? If I go mess with my employer hierarchy, I've done an update here which creates a loop in my hierarchy. A connect by says you got a connect by, it won't let you show it. Exactly the same with the recursive with. You get a different error message, but the same error comes out. You've got a problem in your hierarchy. With connect by, how do we solve it? We do connect by no cycle. And we have this connect by is cycle flag that tells you that, yes, as I went from King to Alan and was heading back to King, I encountered a cycle. So Alan gets a tag of 1, all the others get a tag of 0. Be aware it's a bit different with the recursive one. The syntax is slightly different. We say I'm going to cycle the employee number. If I hit a cycle, I'm going to set a column called isCycle to Y, otherwise default to N. But notice it's actually when I came back to the King row. So a different row gets tagged as Y. King went to Alan, and when Alan came back to King, that's when I set this flag to Y. So be aware, we can still detect cycles, but they're slightly different. One thing you need to know is that cycle column can only be a single character string. If you try yes or no, you get an error. You'd need to do a decode or something around it at the end. You can do 1 and 0, but be aware it's still a string. You can see the values here are left justified because even though I've said 1 and 0, they are indeed actually strings. One of the cool things, why would I use recursive with as opposed to connect by? Well, you get access to a few more cool things. You can actually choose the way you would navigate the hierarchy. For example, I can say I want to search the hierarchy breadth first. So start at the first level, go to the next level, go to the third level. I'm going across the hierarchy first and assign a column to let me do order by. In fact, I should have had order by at the end here. So start at level 1, get all those rows first, then get all the level 2 rows, then get all the level 3 rows, etc., and set a value here that lets me do order by. I can also do search depth first. So the old sort of like navigating through a maze, work your way down, up again, down, etc. So this gets you the start at king, work your way down through the hierarchy, then back up again. Once again, setting an index that you can order by to have that nice ordering in there. I'll leave it at that. So there are genuine reasons why you want to be looking at recursive width. Don't just think about it as solving the Fibonacci sequence, etc. Recursive width actually has a lot of cool facilities and some cool power as well. And on that note, 10:02, a little tiny bit over, but hopefully not too much. Oh, I've got more. What have I got? A Q&A. Someone said, sorry, I should have seen this in the chat, sorry. Let me quickly answer this. Can more than one user be allowed to proxy to a single no authenticated user account? Yes, it is. So you can do multi-user, special account, connect by Scott, connect by Tim, connect by Bill, or connect through Bill, etc. And they can all proxy in. That's fine as well. And there's a sys context variable which will show you who was actually the originator of that. So hope that helps. Let me stop my share. As always, thank you very much for your time. I'm sorry we didn't get through it all because I just talked too much. I'm just too interested in it. My apologies for that, but hopefully it inspires you as well to go play with some of this cool stuff. I'll be in Open World next month, but hopefully my office hours will be slightly after Cloud World. I shouldn't say Open World, should I? After Cloud World. So hopefully there'll be an office hours next month. So we'll cover these remaining ones as well. As always, if you have any questions after the fact, ping me on Twitter. I love hearing your stories, your challenges, your successes. But until then, thank you once again for giving up your time, and I'll see you next month on Office Hours. Bye for now, everybody.